Complex numbers and complex algebra. Not just, oh, it's more complicated than the usual. No, no, no. I mean complex numbers as in the imaginary plane, but it's actually a real plane. This is where imaginary and real worlds collide. So we have two ways of representing them. The complex form of algebra has both a rectangular form and a polar form. With a rectangular form, see, we have this C, or complex number, equals some number x along the real number axis. Remember real numbers, even from grade school, 0. Negative numbers this way, positive numbers this way. And so that's your x plus j, or you may have learned it as I, but in electrical engineering, I is reserved for current. So electrical engineers use J for our imaginary, or in this case, y-axis. And then we just solve for the Pythagorean theorem when we eventually get to converting them to find our hypotenuse. So x is the real part, y is the imaginary part. C is our hypotenuse of the right triangle, which means x, if you remember, a squared plus b squared equals c squared. Well, here we're still keeping this as c. That means what is the length of this line? So the rectangular form gives us our magnitude. It means how long is our hypotenuse. And so we just say if this is 3 units long and this is 4 units long, well, we have 3 squared is 9 plus our j 4. So we just denote this with the j squared. 4 squared is 4 times 4 is 16. So it means 9 plus 16, and take this square root of it will give us 5. Because, well, it will give us 25, and then we take the square root of 25 and it gives us 5. And then we complex conjugate, which we mentioned earlier, maybe in a previous video. We just take the c and then we put the bar over it. C bar is 7 minus. We just changed from the plus to the minus here. If we want to add or subtract complex numbers, there you go. Perform the operations on the x and y separately. If we convert to the polar form, x equals your z, which is your magnitude, times the cosine of theta. And, well, if you have it in polar form, want to convert it back to rectangular form. In order to understand that conversion, we need to look at this card next. So complex numbers, polar form, c equals z at an angle of theta. C is complex numbers with a magnitude and an angle. So it's not just the magnitude, it's the angle as well. Z is the magnitude from the rectangular form, which, as I mentioned, is the Pythagorean theorem. X squared plus y squared will give you c, your complex number. And now that c becomes that this here, which is the hypotenuse, 5, and it includes the angle, this angle down here. How high up off the x does that angle go? So that is the angle theta, which can be also gotten from the rectangular form by the arctangent, which on your calculator will be tangent to the power of -1 of your y over your x. That will give you your angle. Then taken from the time domain, z over square root of 2 to get the RMS, and then revert from back to time domain, z at an angle of theta. You go back to that sine omega t plus or minus theta by square root of 2. Then convert to rectangular. You get back to your x, c equals x plus jy, by taking z, your magnitude, times the cosine of theta, and y equals z times the sine of theta, and that's where I came up with this on this other card, which is basically the same thing. So, complex numbers. Now, going back to that J, with J, it cycles in on itself as it goes counterclockwise around your standard unit circle. At, let's say, 0 degrees, J is equal to the square root of -1. Well, never mind the degrees part. So just J by itself is square root of -1. J squared is the square root of -1 multiplied by the square root of -1, which is -1 squared. Well, if we take something is inside of a square root and we square it, that cancels out the square root, so we just get -1. J squared is -1. And then if we have J cubed, we have -1 multiplied by itself 3 times, so this is -1 times J. Well, -1 times anything is just that thing it's multiplied by. But here it's negative, so there's -J. And then J to the 4th power is -1 times -1 because of this property, and that just gives us 1. And then it cycles back with 5, 6, 7, 8. It cycles on. I'm out of battery, but that's complex numbers. We'll continue in another clip.